All right, today we are going to talk about dividing rational expressions. It's going to be a continuation of what you've been doing with multiplying rational expressions, but let's go ahead and jump in. So first, our warm-up problem. I have 1/2 divided by 1/4. Okay, looks pretty similar to the problems we've been doing except for the division symbol. So I need to first remember, how do I divide fractions? Well, I have this little hint to you. Dividing fractions is the same as, why don't you pause the video, see if you can figure it out. Okay, welcome back. So dividing fractions is going to be the same as multiplying by the reciprocal or reciprocal. So let's jump up to our problem up here and kind of interpret what that sentence means. So 1/2 divided by 1/4 could also be written as 1/2 times, well, the reciprocal of 1/4 would be 4/1. Or we think about it, the flipped fraction here. Okay, so I have 1/2 times 4/1. Well, I know 1 times 4 is 4, and 2 times 1 is 2. But notice right here, after we flipped it, it's pretty much like the problems we did the past days. And yes, I know this answer is 2, but I could also write it like we've been doing in the past 2 days, where I have 4, or the factors of 4 are 2 and 2, over the factors of 2, which are just 2 and 1, so I'm not going to write the 1. And I can then cross out, well, I have a 2 on top and a 2 on bottom, so I'm just left with 2. So like I said, it's like our problems we've been doing in the past, but this little division symbol in the beginning will be changed to multiplication, and we'll flip this second fraction. So let's go ahead and jump in with a problem and practice this idea. So I have 16x to the 4th over 7y squared divided by 16x squared over 49y. Okay? So the first thing I'm going to do is the first thing we did up in our warm-up problem. I'm going to change this from division of rational expressions to multiplication by rewriting this as 16x to the 4th over 7y squared times the reciprocal, or the flipped fraction of the second piece. So times 49y on top over 16x squared. Okay? And just like when you were doing the multiplication of rational expressions, I can look for a diagonal similarity or diagonal factors that are the same, or up and down factors that are the same. So I like to approach it as, is there a 16 somewhere in the bottom, or is there something that can go into 16 or that 16 can go into? Well, yeah, I do have a 16 in the bottom, so I'm going to go ahead and cross those 2's out. Okay, and then I look for, is there an x to the 4th in the bottom, or maybe x is in the bottom? Yeah, there's x squared. But remember, when I have 16x to the 4th, that's really, I have 4 x's, and x squared is really 2 x's. So I'm only going to cancel out 2 of the x's up top, which means I would be left with a x squared right here, but we'll come back to that in a second. But this x squared is now gone. Okay, now I'm looking at this one. Is there a 7 up top, or is there a 7 or something 7 can go into? Yeah, there's a 49 right here. So that 7 will go into 49, and it will leave me with a 7 up top because 49 is 7 times 7. Okay, y squared is really 2y's. Do I have a y somewhere up top? Not here, I've taken care of that one. I do in the second part. So I'll cross out this one y and this one y. And now I gotta figure out what I have left, basically. So I have x squared left. I have times 7 in that second parentheses, and the only thing left on the bottom is y. Now I'm going to write that as 7x squared over y. And here would be a good place to check yourself and see, did I really take out everything that was common in the top or the bottom? Because if you didn't, you'd have something, you'd maybe have y's on both the top and the bottom, or x's on both the top and the bottom. Okay? So we're going to go ahead and move on to another problem, practice this idea a little bit more. The next problem I have, and I'm going to scoot this over so we have more room, is going to be x squared minus 9 over x plus 4 divided by x minus 3 over x plus 4. Okay, before I start to factor, before I do anything, when I've got this division symbol, first thing I'm going to do is flip it. So I really have x squared minus 9 over x plus 4 times x plus 4 over x minus 3. Notice it's the reciprocal of that second fraction, okay? Just like the problems we've done. So now, before I start crossing things out, I'm going to see, is there anywhere I can factor? Well, if I look at this first one, x squared minus 9, I can factor. You should recognize it's a difference of squares. So I would have parentheses that pretty much look the same except for their sign in the middle. So factors of x squared right here, x and factors of 9 are going to be 3 and 3. One of them will get a minus, one of them will get a plus. So I have x minus 3 times x plus 3 over x plus 4 times x plus 4 over x minus 3. And I know you're tempted to all of a sudden, ooh, look, there's an x up top and x up bottom, cross those out. But remember, this right here is one whole factor. This is one whole factor. Whenever you have a addition sign in between two numbers or a subtraction sign in between these two numbers, that's going to make it one whole factor. Okay, so I'm looking for a whole x plus 4 on the bottom, not just a x. But let's jump over here. Is there a whole x minus 3 on the bottom? Yeah, there is, and that's second fraction. So I'll cross those out. Is there a whole, or is there a x plus 3 on the bottom? No, there's not, so I'll leave it alone. Is there a x plus 4 on top? Not in this one, but in that fraction. So I can cross those out, and it looks like I am just left with x plus 3. And that would be my final answer. All right, so let's go ahead and try out a couple more problems. So I have problem number 3 right here. This one's kind of a long one, but it shows a lot of little things that I think will help you guys. So I have x plus 3 squared. I'm going to rewrite that. X plus 3 squared over x squared minus 9 times 2x minus 6 over 5x divided by x squared plus 7x plus 12 over x. All right, I threw one with 3 in there at you, but we're gonna approach it the same way. So first thing, is there any division I need to flip? Yeah, that last part. So I really have x plus 3 squared over x minus 9 squared times 2x minus 6 over 5x times x over x squared plus 7x plus 12. Notice I am now, instead of dividing, multiplying by this fraction's reciprocal. So now I am at the part where I need to start to factor or write things in its factors. So with this first fraction, you notice I have x plus 3 squared. What I'm going to do with that is just write it as x plus 3 times x plus 3. So that helps me visualize, ooh, if I'm going to cancel out this whole factor right here, I need to have 2 x plus 3's on the bottom. I can't just cancel out if there's just one x plus 3 and cancel out both. And we'll kind of see that in a minute. So I have x plus 3 times x plus 3 over, well, x squared minus 9, we just did that one up here, is x minus 3 times x plus 3. Okay, not going to cancel out. I'm going to keep factoring. Could if you wanted to. 2x minus 6. Is there maybe a GCF? Oh, well, yeah. 2 goes into 6 and 2. So I can pull out a 2. So I have 2 times x minus 3 over 5x. And 5x, I can't really do anything with it. X, I can't really do anything with it, but x squared plus 7x plus 12, I could manipulate or factor. So I've got factors of x squared in this first spot, so x times x, and some factors of 12. Maybe I have 2 and 6, maybe I have 3 and 4. I'm going to let you know that it's 3 and 4. You could guess and check that. You could do that off to the side, but it's 3 and 4. Okay? And now I'm at the point where I can start canceling things out. But remember, I can't cancel out things that are next to each other. It has to be up and down or diagonal. So let's start with this first parentheses. I have x plus 3 up top. Is there an x plus 3 on the bottom? Yeah. So I could cancel those out. I have a second x plus 3 up top. Is there a second x plus 3 on the bottom? No. And the third one there is. So I can cancel out this second x plus 3. Remember, I could only do that because I had 1 for each of them. Okay? It wasn't because I had this one that I could cancel out both. They each had a buddy on the bottom. All right, so let's look at this first fraction. I just have one thing left, x minus 3. Okay, there is an x minus 3 right here. So that's canceled out. This first fraction is essentially now just 1. All right, let's keep going. 2, is there something on the bottom that 2 could go into or that goes into 2? No. Oh, we're tempted with this 4, but remember this whole factor is x plus 4, so I can't separate these two. Okay, how about 5? Can 5 go into anything? No. Okay, what about this single x? Is there a single x or a number times x on top? Yeah, I've got this x right here and this x on top. Okay, x plus 4. Is there an x plus 4 up top I don't see one. So let's write what I think we have left is 2 over 5 times x plus 4. Can we cancel anything out? No, I think that's good. I think that's what we're left with. Okay, so that would be my final answer. That one was a little crazy because we had 3 terms, but it works out the same. I can cancel out diagonal even if I have a number over here and a number over here. All right, I have one more problem for us. It's gonna look a little weird, but we're gonna work through it kind of logically. So, number 4, I have, you know what, we're gonna do x to the 4th minus 36 over x squared plus 7 over, so one big fraction line or one big fraction, x to the 4th plus 9x squared plus 18 over x squared plus 3. Okay. So that one looks a little weird. It looks like I have one big fraction, maybe. But let's think about it for a minute. What is a fraction, really? Well, if I'm thinking about a fraction, like if I had the fraction 1 over 2, what does that really mean? Like if I were to plug that into my calculator, I get 0.5. But what's that middle step there? Oh yeah, it would be 1 divided by 2, or how some of you might plug it into your calculator. So a fraction is really just division. So if I have one big fraction here, or we call it a complex fraction, I'll just rewrite that as the 2 expressions, the top and the bottom, being divided. So I have x to the 4th minus 36 over x squared plus 7 divided by x to the 4th plus 9x squared plus 18 over x plus 3 x squared plus 3. Notice I now have the top, or the numerator, divided by the denominator, or the bottom. Like we talked about up here, numerator divided by the denominator is really what a fraction is. And now that I have it like this, I can keep going like we've been doing with our problems. So I have x to the 4th minus 36 over x squared plus 7 times x to the 4th. Oop, I almost forgot the most important part of today's lesson. When I rewrite it, it needs to be times the reciprocal, not times the same fraction. That's a common mistake we see. So times x squared plus 3 over x to the 4th plus 9x squared plus 18. All right, I'm at the part where I need to start factoring. And I've completely ignored the fact that I have higher levels till right now because we've been practicing with those. We should be able to work with those and figure them out. So I have x to the 4th minus 36. Well, to me, that looks like a difference of squares because I know 36 is a square, and I know that x to the 4th is a squared as well. It would be if I had x squared squared. So I can factor that one as x squared plus 6 times x squared minus 6. X squared plus 7, I'll leave alone because it may be like I've got the x squared, but I don't have a difference, and 7 isn't a number squared. So I'll leave that alone. Same reasoning with x squared plus 3. But I could factor x to the 4th plus 9x squared plus 18. So in these first spots are going to be x squared and x squared. And now let's think through some factors of 18. So maybe I've got 2 and 9. Maybe I have 6 and 3. Looking at the middle, it looks like I want my bigger numbers to be positive, or if I look at the last number, both of my numbers have to be positive. So I'm looking for these factors really to add up to that middle. So 2 plus 9 would give me 11. Not going to work. But if I had 6 and 3 right here, that would give me 9 in the middle. And again, you can guess and check that off to the side. So now I'm at the part I'm looking for. Are there any similar factors? So x squared plus 6. Is there an x squared plus 6 on the bottom somewhere? Not directly below it. Diagonally, though, yes. Okay, x squared minus 6. Is there an x squared minus 6 on the bottom? No, no. Okay. Is there an x squared plus 7 up top? No, no. Okay, so I'll leave that alone. Remember, just like before, this x squared couldn't cancel out with that x squared because it's x squared plus 7 as the whole factor. Just like this one is x squared plus 3 as the whole factor. Speaking of x squared plus 3, is there an x squared plus 3 on the bottom? Yeah, right below it. So I can cross those out. This second factor is essentially just 1 now, and it looks like I'm left with x squared minus 6 over x squared plus 7. And again, do not cross out these x squareds because it is x squared minus 6 over x squared plus 6. I'm sorry, plus 7. And that would be my final answer. All right, guys, I hope today you learned something about dividing rational expressions, remembering that it's the same as multiplication, except for when I divide a fraction or a rational expression, I need to multiply by the reciprocal fraction. Have a good rest of your day.